Hello, this is video U. And yes, it's all for you. Professor jokes are even worse than dad jokes, aren't they? Video U is about, I've got types of class member functions. I don't think I'm going to go there. I'm going to call it kinds, because we've already got types flying around all over the place, don't we? Kinds of class member functions. How many kinds can there be? Well, not a whole lot, but a few, and we need to talk about them. Well, I'm going to go back and fall back on my TV abstract data type, which is a list of operations, and I'll even say so. TV ADT operations. And remember, if you want to call yourself a TV, you've got to be able to do these things. And with the TV, you can do these things. You can do this. Turn it on. Otherwise, it's pretty useless, huh? When you're done with it, you can turn it off. Probably in between there sometime, you might want to watch it. Watch TV shows on it. And while you're watching it, you might also listen to it. You don't have to. You can watch it with the sound off. You can listen to it without looking at it. So those really kind of are independent operations. You can display info. On my TV, for example, you push the button, you see the current channel. So I'm going to say display current channel. And maybe even display the current volume. Maybe that's all one button. But you can see what we're doing is we're taking a sneak peek at the state of that TV object. Don't want to give away too much. Maybe you don't like the current channel or the current volume. You can turn up the volume. Turn up or down the volume. That says down. I'll make it look more like it says down. Turn up or down the volume. You can also increment or decrement the channel. I'll abbreviate decrement. Channel. And yes, I know there are lots of other buttons, but those are the only ones I need for now. I'm going to just say a little bit about each one of those. First of all, those are not general kinds of class member functions. These are specific examples of those general kinds of class member functions. This is a general kind of what? Turn it on. That is going to turn into, in C++, if we, yes we are, if we implement a TV data type that's able to do all these things, then this, the member function that does this, is called a constructor. C-O-N-S-T-R-U-C-T-O-R. Makes it sound like it's going to build a TV from scratch. But no, it doesn't really do that. The constructor gets the object ready to use. For example, maybe it's somehow or another saved a long-term storage inside the TV. It saved what the channel was the last time you watched it. When last you watched Downton Abbey, it was on channel 43. So maybe when you turn the TV on, it resets, or not resets, but initializes. Oh, that's a much better word. It initializes the channel to 43 because that's what you were watching last time. It might also initialize the volume to whatever it was last time. So in general, a turn it on member function inside a TV class that's going to implement objects, all this terminology flying around everywhere. The constructor, you can think of that as when you turn it on and get it ready to use, then that's what is executed. Is executed. You don't do this yourself. I'm going to put an arrow with a note here, and all of a sudden I realize I might run into some problems here with space. This is called, by the system, you can think of the CPU as the system that's running your program and executing instructions and going to functions when you call functions. But this is called by the system automatically, A-U-T-O-M-A T-I-C-A-L-L-Y, automatically underline parenthesis, when since I'm talking about TVs, I'll make it specific, when a TV object is created. Holy moly, I'm not going to have space to write after all these things. I should have spread them out more. I don't want to start the video over. That's been the theme of my day today. I'm going to have to complain just a second. This equipment's just falling apart. I hope we make it through summer school. The constructor gets the object ready to use, is called by the system automatically, and I don't have room to squeeze it in up here, but you never call the constructor yourself. Here's what happens. This is going to be the TV class, and the TV objects that we make from that class, that is our homemade data type. If you make a variable of type int, if you say int space count, semicolon, int space team counter, semicolon, int is a data type the system already knows. It knows how to set up that variable, carve out a little chunk of storage for it, give it its own very own hexadecimal address that it's not going to share with anybody else, and voila, it has constructed that integer variable. TV, if that's a class in C++ that we implement with code, that is our own homemade data type. The system does not know how to set that up and get it ready to use. Things like initializing the channel, initializing the volume, initializing whether or not it's muted, all that stuff. That's all internal to our brand new class defining this data type, and the system is going to look to us. It's going to look to us to provide a constructor member function that says how to initialize this thing, how to set it up and get it ready to roll. That's why the system will call that automatically whenever we set up a new variable of type TV. TV space my Sony. Maybe that's the name of my TV. I don't think I've given my TV a name, but we'll say I did. My Sony is the name of my TV. So if I've got a variable that says TV space my Sony, semicolon, that statement alone, it looks like it's just setting up a variable, and it is, but that statement causes the system to call this constructor function automatically. Now, I don't have to put anything in it. If there's nothing really to initialize, the constructor can just be a set of empty curly brackets. And that's your way of saying to the system, you know, I meant to leave it that way. Now, go about your business. There's nothing to do here. Move on. But if there are things we need to initialize, if it's maybe a counter, a new data type just for counters, then maybe we need to set it to 0 before it goes back and actually tries to use the variable. With a TV, okay, now I'm repeating myself. And I'll try to stop repeating myself. Never call this yourself. I'm going to have to switch colors so that I can distinguish this, the description of the constructor, from, wait for it, this thing in blue. That's the destructor, D-S-T-R-U-C-T-O-R. D-E-S-T, one moment please. D-E-S-T-R-U-C-T-O-R. I need it. There. The destructor. What's a destructor do? I bet you could guess. This, I guess you could say, shuts down the object. Now, that is very loosely stated. It's actually, you could think of it as, it cleans up whatever mess there is to clean up before this variable disappears. Remember that discussion of local variables inside function? A local variable inside a function magically appears when you call the function. Voila! That variable did not exist before. When the function returns, goes back to the main program, poof, the variable disappears. As long as it is a system known data type like int or double or string or whatever, it knows how to do that. It does not know how to do that with a TV. You can have a local variable. Any place where an int variable is valid in a function or main or whatever, you can have a TV variable instead and do something different if you wanted to. Inside a function, if I have a TV variable, when I call that function, boom, the system's going to call the constructor. and get that local variable of type TV all set up and ready to roll, or ready to view, ready to listen to. Then when I hit the bottom of the function, goes back to where it came from, it's got to call the destructor, clean up the mess, get it ready to disappear out of memory. So that's why I say it shuts down the object. This is also only called by the system. Isn't that cool? I mean, all these problems we've been having with getting the function calls to behave themselves and get past the compiler errors, we don't ever even call these. We never call the constructor function. We never call the destructor function. The system, the CPU, will do that for us automatically as these variables come and go with their use in a program. Okay, also only, I didn't put only up here, I should have. Also only called by system. By the system. Comma, and I'll state this a little more technically than I just now described it. We ask that you bear with us. Also only called by the system when the object, hang on, goes out of scope. I'm going to put that in quotes, even though that is the way it's described, or that it falls out of scope, like you fall out of a loop. What does it mean to go out of scope? Well, back in happier days, when there were no functions and all we had was the main program, we had variables in there like Fahrenheit temperature or whatever. Those variables that we set up in the main program, those go out of scope when you hit the bottom of the program in the closing curly bracket. Here's a more advanced example. I call a function that's calculating my test average. It has a local variable named average, double space average semicolon. I can visualize that, can't you? That variable did not exist until you called the function and double average, the first line inside that function, that said make me a local variable named average because I'm going to need it to do my calculation. Then when you hit the closing curly bracket at the bottom of the function, it goes back to the main program. But when it hits that closing curly bracket, variable average disappears, goes out of memory. Another way to describe it, the reason it disappears and goes out of memory is because it falls out of scope. It goes out of scope. Scope is a set of curly brackets that contain where that variable was set up. I'm having a flashback. Some of you have experienced that the hard way. I can't use variable I after I'm done with my for loop. For, parentheses, int I equals 0, I is less than max plus plus I, yada, 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 closing curly bracket. When you hit the closing curly bracket of that for loop, your index variable I that you set up just for use in the for loop, poof, it's gone out of scope. It no longer exists. It was destroyed. We don't have to write a destructor for integers or a constructor for integers. Thank goodness for that. We get those for free. But if we've got our own variables, they come and go just like other variables inside groups of curly brackets. I have an open curly bracket. I set up a variable of type TV. When it gets to the closing curly bracket, where I set up, in that statement block, where I set up the TV variable, somehow or another, that variable has got to get out of memory. If there's something we need to do special to get it ready to die, well, that doesn't sound good, does it? Get it ready to be removed from memory, ready for non-existence, prepared for oblivion, then that's what we've got to do in the destructor. That's got to get our variable ready to disappear. And look at all these other lines I've got to say something about. Well, fortunately, a couple of fortunately's. Fortunately, I have more different colors. And also, fortunately, I can group some of these together. I don't know if I did. Yeah, I think I've used that. I haven't used hot pink. I don't see any hot pink on the board. Let's look at these and think about these. Watch it. You can watch it. You can listen to it. You can look at the channel and the volume. Turn the volume up and down, increment or decrement the channel. There is a line I can draw between these and have two groups here, two major groups. Does it have to do with how long the description is? No. I'll stop playing games. It's whether or not they actually even try to change the state of the object. Look at these. Some of these, they're just taking a peek. I just want to know what the current setting is, but I'm not going to change it. Oh, no, that's not my job. My one job is to say what the channel currently is. My one job is to show the TV show so people can watch it. These up here, these three highlighted now in hot pink, yes, right there, those have this in common. They look or examine or observe or access the state of the object, but they do not change it. And I'm making a big deal out of that because it is a big deal. These functions are called accessors. A-C-C-E-S-S-O-R-S. Now, there's some rules. Everybody's got to abide by the rules. These are still class member functions. In other words, these are still functions that will have prototypes in the interface, the actual functions in the implementation. Listen to me using all those big words that are in recent videos. So yes, these functions still have to be written. They still have to be inside the implementation of the object, but they are restricted. These can access or see, I'll put it quotes, these can see the state of the object. There's another term. I'm trying to use the OOP lingo here. The state of the object. In other words, they can look and see what the values of the private variables are. That's exactly what that means. They can see the state of the object. They can see what the current channel is. They can see what the current volume is. But they cannot change it. Some of the rules, this might seem strange, but some of the rules regarding facilities for object-oriented programming in C++ are kind of to protect you from yourself. Seeing what channel the TV is on, that has no business changing the channel up or down or from channel 3 to channel 13. You should be able to access or look at the current channel and not have to worry about it accidentally being changed or maliciously being changed or anything else. So these actually perform a very valuable function. They let you know what the state of the object is, because remember, you can't access that directly. Those private variables are not accessible at all in the main program. The main program is blissfully unaware they even exist. That's part of that gory technical detail stuff that I want you to hide from me. Put that behind the curtain so I don't have to worry about how all this works. All I got to know is how to push the buttons to make things happen. Okay? So, these are very important. Accessors can only see, and I haven't used green, so I should, pardon me, I shall use green for the last two. What are these last two? This is not at all how I planned, by the way, but I hope it's still legible. These last two, turn the volume up, turn the volume down, increment or decrement the channel, those do change the state of the object. Now, they have the potential. Let me rephrase that. There is a minor exception. I said they change the state of the object. If you say put it on channel 5 and it's already on channel 5, it doesn't really technically change the state of the object, but in some ways it does. It puts an new 5 on top of the old 5. So yeah, I'm going to say these do change the state of the object. And they've got a cool science fiction name too. These are mutators. Sound like X-Men, doesn't it? Mutators can change the state of the object. Can. They do have that power. Am I saying A or the all the way through? The. Can change the state of the object. So when we have a member function that's a mutator that says change the channel to this number, that does change the state of the object because it has the power to do so. And there is a C++ language facility that allows us to tell the compiler, okay, I want these to be accessors, I want those to be mutators. Here's my constructor for the object, here's my destructor for the object. So all of this actually is supported. In other words, it's possible to do it. All of this is supported by C++ syntax for classes. Speaking of C++ syntax for classes, the next thing we're going to do is quit messing around and actually look at some of this stuff in C++ code. but I don't want to go there right now because the code is pretty big. That might even be several videos, who knows. But here are the different kinds of memory functions, and we will see those in action next time. But for now, I'm going to say see you online.